Today I want to share a possibly OP motor sharing mechanism that I discovered while working on my ratchet tutorial video. It has two main parts, one for spinning the flywheel, and another for opening and closing the trapdoor. This is still just a test bed of sorts. It's not going to have everything positioned and tuned as it would be when I go to put this on an actual competition robot. There are 3 ratchets on this device. 2 on the flywheel, and 1 two-way ratchet on the trapdoor system. The ratchets on the flywheel force the flywheel to spin forwards no matter which way the motor is spinning. The two-way ratchet on the trapdoor allows for the trapdoor to be powered up until it meets a certain amount of resistance. Once a certain amount of force is required to move the trapdoor any further, the ratchet clicks over and begins ratcheting from that side. Once it does that, the motor can keep spinning in the same direction until you want to change the position of the trapdoor. When the motor changes direction, the two-way ratchet powers the door until it meets resistance, at which point the ratchet will click over to the other side and begin ratcheting that way. You would think that it would be easy for a ball to simply push the door up when it's meant to be down, and overcome the required resistance holding the door down. I have found a way around that. The linkage that powers the door down doubles as an Overcenter Lock. This is a similar mechanism to the one that I used to hold down my flip-down intakes last season. The general idea behind Overcenter Locks is that the arm can't be pushed back once the powered bar has gone beyond a certain point. The power bar can still be powered back, but it can't be forced back via pressure to the arm. The main downsides to a system like this are that the flywheel physically can't spin backwards, and the fact that the trapdoor can't be anywhere in the middle. It is either up or down. There's really no way to keep the trapdoor in the middle while powering the flywheel. The possible states of the motor are off, forwards, and backwards. When the motor is in the off state, nothing moves. When it's in either on state, the flywheel spins. Fancy gearing is used to ensure that the flywheel only ever spins forwards regardless of the motor direction. The direction that the motor spins is used to determine which state the trapdoor is in. If the motor spins forwards, the trapdoor is down, and if it spins backwards, the door is up. Just by modifying what the mechanism's responses are to the different states of the motor, we can practically power 2 separate systems at full power simultaneously while only needing 1 motor for the entire system.